Our next example, number 4. How many grams of sodium lactate should be added to 1 liter of a 0.15 molar lactic acid to form a buffer solution with a pH of 4.00? We'll assume that no volume changes occur during the process of adding the conjugate base of the lactate ion. So we have a buffered system containing an acid with its conjugate base lactate. The Henderson-Hasselbalch will show pH is equal to pKa plus the log of the ratio of base over acid. The sodium lactate is the base, the conjugate base of our lactic acid. The base becomes the variable we'll pull out using the Henderson-Hasselbalch, and from there we can use molarity problems to find grams. So we'll begin. The pH given to us, 4.00. pKa, remember P is just for saying negative log. The negative log of the Ka of lactic acid. We've looked that up before, and I'm just pulling that from problem 1 above. 1.4 times 10 to the negative 4th pH units, plus the log of the ratio of base, which we don't know, but we do know the acid to be 0.15 molar units. Let's simplify so far. We have negative log of 1.4 E negative 4. That's getting a pKa value, and that to me is 3.85. So what we'll need to do now is just 4 minus that answer to bring it to the left-hand side. So we have 0.146 is equal to the log of the ratio of base over acid, 0.15 molar solution. Remember, to get rid of log, it sits on top. The opposite of log is a base of 10. So 10 raised to the power of 0.146 is equal to the concentration of our base over 0.15. The opposite of log is 10 raised to that power. So I'll hit 10 raised to the power of our answer, and that gives us 1.4 is equal to the base over the acid. We'll cross multiply for the concentration of our base. 1.4 times 0.15, and I get an answer of 0.21. What that's showing us is the concentration of the sodium lactate to be 0.21 molar solution. We need to do some molarity work to actually pull out grams. 0.21 molar is equal to X moles per liter of solution. So knowing that we have a 1 liter solution, cross multiplying, we also have 0.12 moles of sodium lactate, whose formula is provided as NaC3H5O3. We'll need a molar mass. Let me add that for us. Sodium is 23, plus 5 more on the hydrogen, 12 times 3 on the carbon, plus 16 times 3 on the oxygen. I found 112 as the molar mass. Mole times molar mass will solve for our grams of sodium lactate. Let me add the molar mass just to check my calculator. 23 plus 12 times 3 plus 5 plus 16 times 3. Yep, I got it twice. So I'm going to say it's 112 times the 0.21 molar solution, and that gives us a value of 23.52 grams of sodium lactate, NaC3H5O3.